Welcome to mathematics classes. Recently, one of the subscriber actually asked me to make a video on the NMTC solutions for the stage 1 and stage 2. So I'm making this video. Hopefully, it will help a lot of people who are preparing for NMTC. Okay, this is the 2024-25 paper, NMTC stage 1, and this is inter-level, okay, which is meant for class 11 and class 12. But if students who are preparing for 𝑖𝑣𝑒+𝑣𝑒, they can actually use this one. This is of the same level. Okay, so this is Ramanujan contest, okay, which is meant for class 11 and class 12 of the NMTC, National Mathematics Talent Contest. Okay, so let's get into this, understand how this one. Okay, so this is as I mentioned, this is a stage 1 paper. So stage 1 paper consists of 30 questions, 2 hours. Okay, part A will have 15 questions, all are 1 mark questions basically, but they have multiple choice. Part 1 is multiple choice, 15 questions. Part 2 will be fill in the blanks, 15 questions. Okay, that's the only difference. Otherwise, both carry same marks. Okay, so now let's get into it. Yeah, the first question is let 1 plus 1 by 2 plus 1 by 3 up to 1 by 6 is m by n, where m and n are positive integers with no common divisors other than 1, which means basically they are written in the simplest form. GCD of m comma n is 1. The highest power of 7 that divides m is, okay, this is a very straightforward question, simple. Take the LCM, okay, and do it. Simplified, what you will get is 147 by 60. If we need in simplest form, okay, so divided by 3, what you will get is 49 by 20. Here m and n has no common divisors, correct? So m is 49, n is 20, and what we are looking is m. So m is 49, which is 77 square. So highest power of 7 that divides m is 2 basically. Okay, right? 7 square will divide this number basically. So answer is C. Okay, this is an easy question. Yeah, next. 5 spherical balls of diameter 10 centimeters each fit inside a closed cylindrical tin with internal diameter 16 centimeters. What is the smallest height of the tin? Okay, so let's first draw the diagram, simple diagram. Okay, you will understand. Okay, this is the tin. Tin width is diameter is 16 centimeters, and the spherical ball diameter is 10 centimeters. So if you put 10 centimeters, second ball cannot be put next to it, right? It will come something like this. Okay, something like this. This is how it is, the arrangement of the 5 spherical balls inside the 16 centimeter diameter tin. Okay, now let's calculate what is the smallest height, possible height of the tin. This is height we need to calculate. So let's put some numbers to it. Okay, so we know that this is AC 16 centimeters, which is given. Okay, and this is 5 centimeters. So obviously IO also 5 centimeters. Okay, and this is 5 centimeters. BC is also 5 centimeters. So obviously OB will be 6 centimeters. Now it forms a right angle triangle here. So I can easily find out what is the value of PB. Correct. So let's see what is PB. IO is 5 centimeters, which I know. Bottom is 5 centimeters. Okay, now if I find the height between two diameters, that is, sorry, two centers, that is PB. Okay, not the distance between two centers, that is 10, I know. Correct? I want the PB. So this is 5, this is PB. Okay, from here to here also PB, from here to here also PB, here to here also PB, and then 5 centimeters, right? That's what I'm looking at. So if I find PB, then I get all the required values, correct? So calculating the height between two centers, that is OP. OP is, we know, 10 centimeters. Okay, and AC is 16. AC is 16. So OB will be 16 minus AO minus BC, which is 6. So OB is 6. This is 10. So I get my PB. Okay, OBB is the right angle triangle. So BP is nothing but, or PB is nothing but square root of 10 square minus 6 square, which is 8. Now I have my 8 here. Now this is the distance between any two center, height between any two centers, correct? So that is 8, 1, second 8, third 8, fourth 8, and then obviously after this one, after this, between these two is 8. After this I have another 5 extra, right? Radius of the sphere. So total height of the tin, or minimum height of the tin, will be 5 plus 8 times 4 plus 5. Okay, bottom 5, top 5, and 8 fours, which is 42 centimeters. So B is the answer. Okay, so hope you understand how to do this one. This is not exactly easy, but little I can say moderately hard. But if you are really preparing for Olympiad, I think this is easy. Okay, so this is moderate, I would say. Next, the expression 7n plus 18 by 2n plus 3 takes integer values for certain integer values of n. Okay, the sum of all such values of expression is. Okay, what are the this expression takes integer values for certain integral values of n. Okay, so first find out for some integer values this is an integer value. Okay, now I need all such values. Okay, so first thing is this is a fraction, correct? So fraction I want to simplify it. Okay, I want to take the integral part out. Okay, and n plus 9 divided by 2n plus 3, right? Now once I know this one, I want to substitute values of n so that I can get some value out of this one. Okay, why I choose this one, not this one? Okay, here you don't know when to stop. Here I don't know that when the numerator and denominator has n and 2n, right? So obviously at some n value, denominator will increase more than numerator. Okay, so that time I can stop it. Okay, I don't require because it won't give me any more integral values. Okay, after some certain values. Okay, so let's check the values. This is simple counting method. So make a table. Okay, so my n values are here, my n plus 9 by 2n plus 3, because this is what will decide when to stop basically. Okay, so if I take n equal to 0, this is 3, so that's good. So it's integral value, so I'll add it. 6, 3 plus 3 6. N equal to 1, this value is 2, so it is 5. N equal to 2, it is 11 by 7. So there is a possibility that I can get an integral value later, right? So I will continue. If it n equal to 3, it is 12 by 9. N equal to 4, it is 13 by 11. But there is no integer. This is still a fraction. Okay. This is basically 4 by 3. Still it's a fraction. Okay. N equal to 5, 14 by 13. N equal to 6, it is 1. Okay. So integer value. So 1 plus 3, which is 4. N equal to 7, it is 16 by 17. Now I will stop it here because after this everything will be a denominator is greater than numerator. So I always get a fraction between 0 and 1. Correct? So I'll stop it here. But don't stop it here. You have negative values also. They just mentioned integer, not positive integer. So check for the negative values also. So minus 1, I have an integral value. So it is 11. Minus 2, integral value. Minus 3, minus 4, minus 5. Okay. As you see here, actually, minus 5, minus 6 onwards, denominator is increasing. Okay. But at minus 9 is a special case at which this expression will become 0. So you should consider that also. Okay. Otherwise, you can stop it actually at minus 5. But minus 9 is a special case where this expression fraction will become 0. So I am considering that where the value is 3. So now all I need is sum of all these values, right? All this third column, all the values, sum, basically that is nothing but 28. That's option B is the answer. Okay, hope you understand when to stop the counting. Basically every counting method you should know when to stop it. Okay, so that is the most important thing. The terminator condition for termination is most important. Okay, so this is how you can solve this problem. This is actually easy problem. It's a counting method. Okay, option B. Okay, moderate I would give because you need to check negative terminating condition, and most of you might make a mistake here. You will come here and stop. Okay, you will come to minus 5, minus 6 and stop. You will not go to minus 9 actually. Okay, that is where you may make a mistake. That's why I'm just giving it as moderate. Next, P is a point inside ABCD such that PA equal to 2, PB equal to 4, PC equal to 5 and PD equal to 6. The maximum area of quadrilateral ABCD is. Okay, so first draw the diagram for such things. Okay, this is my ABCD quadrilateral. P is inside some number. PA is 2, PB is 4, PC is 5, PD is 6. Now, what is the maximum possible value of area of the quadrilateral ABCD? That's the question. Okay, so the area of triangle where two sides are given is area of the triangle where two sides are given. That is, suppose if I take APB and 2 and 6 are given, correct? So area of the triangle is 1 by 2 into product of sides into sine of angle between them, correct? Product of these two and sine theta, suppose 2 into 6 into sine theta here, right? This is what we know. So 1 by 2 into xy into sine theta. Theta is the angle between sides x and y, okay, whose lengths are x and y. Basically, this is the area of a triangle. Now, the maximum area of the triangle where two sides are given is when the theta is 90 degrees, correct? So, which means half into xy into sine theta. sine 90, which is half xy. Okay. So maximum area of ABCD is when this point makes 90 degrees to all the joinings basically. Okay. So which means they are the diameters and intersect at 90 degrees. So which means maximum area is half into 2 into 4 plus 2 into 6 into 6 into 5 plus 5 into 4, which is 35. This is the maximum area which is possible. That's what is the question. Correct. So option C is correct answer, which is, yeah, straightforward. This question is. Okay. So yeah, this is easy. Next. The value of 3 to the power of 4 by 3 minus 3 to the power of 1 by 3 whole cube plus 3 to the power of 5 by 3 minus 3 to the power of 2 by 3 whole cube up to 3 to the power of 10 by 3 minus 3 to the power of 7 by 3 whole cube. Okay. If you observe the pattern, actually, the power of 3, okay, increasing in both cases. Okay. If you call this A and B, both A and B terms, power is increasing. 4 by 3 here, 5 by 3. 1 by 3 here, 2 by 3. 5 by 3 increased to 6 by 3 and up to 10 by 3, and this 1 by 3 has increased up to 7 by 3. Okay. So basically there are total 7 terms and you need to find out. One way you can do is simple way, I mean very raw way, you expand this is just a cube, right? This is just a power 3. So you can say a cube minus 3a square b plus 3ab square minus b cube. Every time you expand, you will definitely get cube terms will get cancelled with the by 3s, and then you will get common terms, you will get the same answer, similar answer. But that is bit, you need to make sure that all 7 terms expansion without any mistake. Okay. So other way is simple way. Okay. If you see, everywhere I can take this second term. If you call this b term, I can take this common. Okay. Right. So this is the given expression. I am taking 3 to the power of 1 by 3 common from this. Okay. Which means it is 3 to the power of 1 by 3 whole cube. And I am left with, if I take 3 to the power of 1 by 3 out, this is 3 to the power of 1. 4 by 3 minus 1 by 3 is 3 by 3, which is 1. Correct? So this is nothing but 3 minus 1 whole cube. Okay. Multiplied here, right? Plus second term also I am taking again this b term, which is 3 to the power of 2 by 3 whole cube common. So I am left with again 5 by 3 minus 2 by 3 is 3 by 3, again 1. So 3 to the power of 1 minus 1 whole cube. Okay. And so on. For all the terms, I am left with very simple equation now. Okay. Which is 3 to the power of n by 3 whole cube, which means 3 to the power of n. N runs from 1 to 7. Correct. So this is nothing but 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, 3 to the up to 3 to the power of 7. Okay. Which is here addition. And then this term is common for all. 3 minus 1, which is 2. 2 cube is common for all. 2 cube is here. Okay. Now this is very simple. Correct. This is a GP. So this is nothing but 8 into 3 times, which is a into 3 to the power of 7 minus 1 divided by 3 minus 1, which is 12 times 3 to the power of 7 minus 1. Okay. Which is nothing but a. A is the answer. Okay. Hope you understand how to do this. Yeah, this is a easy question. Next. 100 people are standing in a line and they are required to count off in fives as 1, 2, 3, 4 and 5. Okay. And so on from the first person in line. Okay. 5 and then repeat basically. Anyone who counts 5 walks out of the line. Okay. So fifth person, every fifth person will go off. Those remaining repeat this procedure until 4 people remain in the line. Okay. What is the original position of the in the line of the last person to leave? Okay. So the question is, do you have 100 people here? You basically remove every fifth person out. Okay. Each one has numbers. Okay. All the persons have numbers 1 to 100. Each fifth person you remove. Okay. You count 5 and remove the fifth person out. Now you are left with a smaller cube. Again, you count 5 and remove the fifth person out. And the question is, you will repeat this until 4 people are left. Because after that, you cannot remove fifth person, right? So the question is, who is the last person leaving the line? Okay, what is his number, original number? That's the question. Okay, so this is an interesting question. I don't say tough or moderate. It is easy. It's a counting problem, but question is very interesting. Okay, so this is how we should do. We know every fifth person is divisible by 5, correct? Right? In every round. Okay. So we need to understand who is the last person after every round. That's all we need. Okay. That means you make a table. Okay. Sorry, this is a table. Okay. The table is here. Okay. Initially, there are 100 people. correct? And the last person number is 100, correct? That is the number I am giving to the person. Okay. Now, how many 5 multiples this 100 is? 20, means 20 people will live, correct? So 20 people, and I know that last number is 100. So this is divisible by, correct? 100 is divisible by 5. So this person will leave. Last person also will leave, correct? So the last person will, in the second round, the last person will be 99. And I am left with 100 minus 20, which is 80 people. Now I know that 80 also divisible by 5, which means last person will leave, correct? So that means 99 will go off, 98 will remain. Okay. And how many people total stay there? 80 by 5, which is 16. So 16 people will go off, and I am left with 80 minus 16, which is 64. Okay. Now, when it is 64, this is not divisible by 5, which means last person won't leave. Correct? Others will go, others will leave the line, but last person will not leave. Correct? So 64, how many will leave? 64 divided by 5, I get 12. Okay, and of course some remainder will be there, but those people won't leave. Okay, so 12 people will leave. So 64 minus 12, which is 52, and 98 is still staying in the line. Okay, similarly you check. So after this, there is no number which is divisible by 5. Okay, up to the last, almost last, where you have 5 people. Okay, when 5 people are there and last person is 98. Okay, only one person will leave, that is 98. He will leave. He is the last person to leave the line. Now I am left with only 4 people. Now no more counting. Correct. So last person, last fifth person walk away from the line is 98. So that's the option C. Okay, hope you understand this counting problem. Okay, this is I gave easy because this very simple counting problem, though it is the interesting problem. Okay, next. The number of positive integral values of n for which 1 factorial plus 2 factorial plus n factorial is a perfect square is. Okay, what is the number of positive integral values possible? Okay, so now that means you may have a doubt saying that when will I stop n? Correct. If I take n as 1, okay, it is 1 factorial. I know it is perfect square. Correct. So 1 is a solution. If I take 2, 1 factorial plus 2 factorial, which is 3, is it not a perfect square? But when I will stop? That's the question. That means the question itself has some limitation, right? That you need to understand. If you count first few, you will understand that. Okay. So let's check this one. Okay. Let's call this sum as s of n. Okay. Sn is nothing but Sn minus 1 plus n factorial. Sn minus 1 up to previous sum plus n factorial. Correct. Now check for the small values of n. For n equal to 1, S1 is 1 factorial 1, which is a perfect square. N equal to 2, S of 2, which is 1 plus 2 factorial, which is 3, not a square. N equal to 3, S3 is nothing but S2 plus 3 factorial, S2 is 3, 3 plus 3 factorial, which is 6 plus 3, which is 9, perfect square. 4 is S of 3 plus 4 factorial, which is 33, not a square. N equal to 5. Now this is the important one. Okay. N equal to 5, you get S of 4 plus 5 factorial. What is 5 factorial? 5 factorial is 120. Okay. You have a 0 in the end. So after 5 factorial, every factorial will have a 0 in the end. Correct? Every 5 factorial, after 5 factorial, every factorial has a 0 in the end. Units digit as 0. Which means the overall units digit will be same as S4. What is S4 units digit? 3. Correct? And we know it is very simple. For n of I, it is 153, but you don't need to worry about what is the total. Units digit is 3. Okay. And if you look at all perfect squares, 3 is not part of the perfect square. Correct. 3 is not any perfect square. If you take any integral perfect square, it always ends in either 0, 1, 4, 5, 6, 9. That's all. There is no 3 in it. There is no 7 in it. Correct. There is no 2 in it. So those numbers you can ignore, which means here after 5 factorial, every number is ending with 3, which means they are not perfect squares. So there are how many possibilities? Only 1 and 2, which is 1 factorial and 3 factorial. Sorry, n equal to 1 and n equal to 3. These are the two values of n where the given expression is a perfect square. So only two options are possible. That is C. Okay, only two perfect squares. So this is also easy actually. Yeah. So next. When 2025 to the power of 2026 minus 2025 is divided by 2025 square plus 2026, the remainder is what? Okay, this is a very good remainder problem actually. Okay, only thing is they gave numbers here. First thing is you make these numbers into uh, some variable. Okay, that way you will understand this problem very easily. Okay, so let's take 2025 as n. Then my question is nothing but n to the power of 2026 minus n congruent to x. What is the remainder? When mod with n square plus 2026, I am writing it as n plus 1, 2025 plus 1. Okay. So this also I can write n to the power of n plus 1. Okay, that's fine. Okay, now I am looking at a number which when divided with n square plus n plus 1, what is the remainder? Okay, now something should strike when you say n square plus n plus 1. Okay, this is a very important. When you keep solving more and more problems, you will understand what is the importance of n square plus n plus 1, right? So n cube minus 1 is nothing but n minus 1 into n square plus n plus 1. Okay, this is a very important equation to remember, formula to remember in this powers. Okay, n cube minus 1 cube, or a cube minus b cube is nothing but a minus b into, okay, a square plus ab plus b square, right? So this is what that is. Okay, now once you know this one, that means from this one I can say that n cube minus n congruent to 0 when modulus with n square plus n plus 1. Or if I take this 1 to other side, n cube is congruent to 1 modulus with n square plus n plus 1, which means if I divide n cube with n square plus n plus 1, I get 1 remainder. Okay. Now I have big n to the power of 2026 here, which I can actually replace with this n cube and see how many n's are remaining, correct? So n to the power of 2026, I can write it as n to the power of 2025 into n, and this I can write it as n cube whole to the power of 675 into 1n. Okay, which means all these remainders are 1. I am left with only n, right? Remainder theorem, if I substitute this one, n cube is 1 remainder. If I divide with n square plus n plus 1, so this is 1. So this is nothing but n into 1 minus n congruent to x modulus, sorry, modulus is missing, modulus n square plus n plus 1, which means n minus n, which is 0, correct? So x is 0, remainder is 0. Okay, so option A is correct. Hope you understand this problem. This is a very good remainder theorem problem. Okay, so I said easy because if you are really working on Olympiad, remainder theorem is the first thing you will be learning, which is very important. Once you know this step, okay, you will definitely solve this easily. Okay, that's why I gave it easy. If you think this is moderate, you have to work on your remainder theorem problems more and more. You can watch my videos, okay, shorts and videos on remainder theorem. Okay, so prepare well. Okay, next. Let n equal to square root of 27 plus square root of 23 whole to the power of 6, where the square brackets means greatest integer function, GIF, the remainder when n is divided by 1000 is. Okay, so first thing is you should find out this n. Okay, and n is within a GIF of this value. Okay, so integer value of this square root of 27 plus square root of 23 whole power 6 we should find. Okay, so let's do. So first thing is, if you look at square root of 27 plus square root of 23, this is 25 plus 2, 25 minus 3 actually, almost very close numbers. Okay, so if you call a as, let a is equal to square root of 27 plus square root of 23, and b is square root of 27 minus square root of 23. Now we know that this difference is very, very small, fractional, all right, that is 0.4. This is fractional value. Now all I need is a to the power of 6, which is nothing but n. GIF of a to the power of 6 is n. Basically, I need a to the power of 6 first. Correct? So how do I get a to the power of 6? Okay, if I take a to the power of 6 plus b to the power of 6, then this is a plus b whole to the power of 6 plus a minus b whole to the power of 6. Correct? I can cancel many terms. In this 3 terms I can cancel. Correct? So let's do it that way. All we need is a to the power of 6. A to the power of 6 plus b to the power of 6 is this one, square root of 27 plus square root of 23 whole power 6 plus square root of 27 minus square root of 23 whole power 6. So total 7 terms in each. 3 terms are negative from this, which gets cancelled. Other 4 terms will be doubled. So 2 times square root of 27 whole power 6 plus 15 square root of 24 to the power of 4 square root of 23 square plus 15 square root of 27 square root of 23 whole to the power of 4 plus square root of 23 whole power 6. Now, if you see, all the powers are even and square root is there. So that means square roots gets cancelled. You will get a integer value. Okay, carefully do it. You will get 9,95,200. Okay, this is the value you will get, a to the power of 6 plus b to the power of 6. Now you understand, b is already a fractional value. So b to the power of 6 is definitely fractional, still within 0 to 1, correct? b is 0.4. So b to the power of 6 also between 0 and 1 fractional value, smaller than this, in fact, 0.4. Okay, which means a to the power of 6 plus b to the power of 6 is equal to 9,95,200, or a to the power of 6 is nothing but 9,95,200 minus some fractional value, correct? Not even 1. Okay, I am reducing less than 1 value. So if I make GIF of this a to the power of 6, what I get is 1 less than this value, correct? 1 less than, because this is fractional, less than 1, between 0 and 1 basically, correct? So all I get is GIF of a to the power of 6 is 9,95,199. Now all I need is remainder when it is divided by 1000, which is nothing but 199, which is option D. That's the correct answer. Okay. So yeah, this is definitely a moderate problem. You need to apply a little bit of logic here. Okay. Next. ABC is a triangle. D lies on AC such that AB equal to BD equal to CD. All angles are whole number of degrees. That is important. Whole number of degrees. Okay. The largest possible angle in degrees of angle ABC is. Okay. So first draw the diagram. Okay. Diagram is simple. You have a ABC triangle and there is a D here. D is such a way that AB is equal to BD. That means these two angles are same. Let's come to how this angle came, but these two angles are same. BD equal to CD, which means these two angles are same. Okay. Now all I need is angle ABC, this complete angle here. Okay. So let's call this angle X. So and this is Z. This you can actually call 180 minus 2x already, but you can call it Z. If this is Z, this is 180 minus Z. This is, these two are same, so it is also 180 minus Z. So this will be 180 minus sum of these two, which is nothing but 2z minus 180. All I need is angle ABC is nothing but angle ABC I need basically, correct? So angle ABC is 2z minus 180 plus x. Okay, this is what I need. Okay, now z is nothing but 180 minus 2x. So if I substitute it, 180 minus 2x, if I substitute, I get 360 minus 4x minus 180 plus x. Okay, if I simplify, the angle I get is 180 minus 3x. Okay, now for the largest angle ABC and each angle being integral whole number, okay, whole number, x has to be greater than 0. So minimum angle for x is 1 degree, correct? If I take 1 degree, okay, if I take 1 degree here, angle ABC, which is maximum, that is 177 degrees. Okay, hope you understand this one. Okay, this is the answer. Option D is the correct answer. Okay, yeah, this is easy. You have to just populate the angles correctly. That's it. Next. The side lengths of a right angle triangle are in geometric progression. Okay, and the smallest side has length 2, then the length of hypotenuse is. Okay, so let the side of triangle be ABC, sides are ABC, A being smallest. Okay, A is less than or equal to B, less than C. Okay, because C will be hypotenuse anyway, so it cannot be same as these two, but A and B can be same. And smallest is 2 units, so A is 2. Okay, once I know this one, Pythagoras theorem, c square equal to a square plus b square. Pythagoras are Bodhayana theorem, right? Okay, and then I also know that ABC are in GP. Okay, geometric progression. So b square equal to AC. So substitute here AC. All I get is c square equal to a square plus AC. Now a is 2. Substitute it. C square equal to 4 plus 2c. Now we will form a quadratic equation, right? Just solve it. This is a quadratic equation. C is nothing but 2 plus or minus square root of 4 plus 16 divided by 2, or 1 plus or minus square root of 5. 1 minus square root of 5 will give you negative value. Side cannot be negative, so you ignore that. Correct? So C is equal to 1 plus square root of 5. That's the answer. This is the hypotenuse, right? C is the hypotenuse. So option A is correct. Okay, yeah, this is also easy. Just you have to apply GP rule and hypotenuse rule. I mean Pythagoras theorem. Next. In a regular polygon, there are two diagonals that intersects inside the polygon at an angle of 50 degrees. The least number of sides, the polygon for which this is possible. So this is one question I did not attempt actually. I saw the solutions by others in many ways, but I have my own doubts actually whether they consider the diagonals, all diagonals intersecting at one point, or if you see any polygon, actually a regular polygon, not it is not sure that all the diagonals will intersect at same point. First thing, okay, some of them may not. So I'm not sure whether everybody considered all those possibilities before making. The answer given is 18, but I really did not find a convincing solution for this one, and I myself could not get convinced actually. So I'm not attempting this question. Okay, next. In triangle PQR, angle R equal to 2 times angle P, PR equal to 5, QR equal to 4. The length of PQ is, okay. So look at the diagram, you will understand very easily. This, if this angle is X, this is 2X, okay. And QR is 4, PR is 5, and let's say this is Y, okay. Then we need to find out PQ, which is Y, correct. So all we need is to have two angles and two sides. We can apply sine rule basically, right? Angle PQR is equal to 180 minus 3x. Obviously, we know it is. You can now apply sine rule. Sine x by 4, sine x by 4 equal to sine 2x by y equal to sine 180 minus 3x by 5. Correct? Now you expand this again. Sine x by 4, sine 2x is nothing but 2 sine x cos x by y. Sine 180 minus 3x is sine 3x. So sine 3x also you expand it. It is nothing but 3 sin x minus 4 sin cube x. Now sin x is common in all this, so cancel it. You are left with 1 by 4 equal to 2 cos x divided by y, which is equal to 3 minus 4 sin square x by 5. Excuse me. Now you take 1 by 4 equal to 3 minus 4 sin square x by 5. Simplified, what you will get is 5 equal to 12 minus 16 sin square, or sin x equal to square root of 7 by 4. Now you can just build a right angle triangle and find cos x, or you apply sin square x plus cos square x equal to 1, find out the cos x. Cos x is nothing but 3 by 4. Now cos x, if this is 3 by 4, my y is nothing but 2 into 3 by 4 into 4, correct? That is 6. 8 cos x is y. So if cos x is 3 by 4, y is 6. This is the y is what I am looking at. So this is option B. Okay, that's this is also easy actually. You just need to apply sine rule. Next. Each of the 10 people around a circle chooses a number and tells it to the neighbor on each side. Okay. There are 10 people sitting in a circle. Each one choose one number and tell it to both sides, left side and right side, that number. Okay. So each person gives out one number and receives two numbers from their neighbors, two neighbors, right? The players then announce the average of the two numbers they received. Okay. The announced numbers in the order around the circle are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The number chosen by the person who announced the number 6. Okay. Whoever announced 6, what is the number he has given to 5 and 7? That is the question. Okay. So this is, let's say, the original numbers each person has given to the neighbors is x1, x2, x3 up to x10, let's say. Okay. Now I know that x2 is average of x1 and x3, correct? X2 is average of x1 and x3. Similarly, x3 is average of x2 and x4, correct? Since I am finding 6, I want to have even numbers. So I will consider even lot here. So x2 plus x4 divided by 2 is x3, correct? x3 is nothing but 3. So x2 plus x4 is 2 times 3, which is 6. Similarly, x4 plus x6 is 2 times 5, which is 10. x6 plus x8 is 2 times 7, between the number, right? 7th person they gave this. Okay. So 14, and x8 plus x10 is 18. Okay. Now x10 plus x2 also come back. Okay. It's a circle. So is 2. Now you sum up all these things. Okay. Sum all this LHS side and RHS side. Okay. What you will get is 2 times x2 plus x4 plus x6 plus x8 plus x10, which is equal to all the sum which is 50. So sum of these x2 plus x4 plus x6 plus x8 plus x10 is 25. Now I know my x2 plus x4 is 6, x8 plus x10 is 18. So if I substitute those two here, x6 is nothing but 1. That's the answer. Option D is the correct answer. Okay. Hope you understand this one. A regular octagon is formed by cutting off 4 equal isosceles right angle triangles from the corners of a square of length 1. The area of octagon is how much? Okay. So we need to find out, this is a regular octagon, which means all sides are same. We need to find out area of this one, which means we know the area of square, which is 1 into 1 because side is 1. 1 minus cut off this a square by 2, a square by 2, a square by 2, a square by 2. Okay. What is this here? I need to cut the isosceles isosceles right angle triangles, and all 4 are same size, which means if I take a side, side A, this is also a side. Okay. And this will be square root of 2a. Since this is a regular octagon, this length, side length is same as this side length. Correct. So on 1 unit of side of the square, I have a plus square root of 2a plus a. Correct. So this is the equation for us. Okay. So a plus square root of 2a equal to 1, or a is equal to 1 by 2 plus square root of 2. Now all I need is area of the regular octagon, which is nothing but 1, which is square, this whole square 1 into 1 minus 4 times a square by 2. Now it's all about substituting this value and simplify it and make the third with only numerator third basically. Okay, don't keep the third in the denominator. Okay, anytime you see a third in the denominator, you try to change it to, otherwise this is the answer, right? This is the answer. I can keep third in the numerator and denominator, this is the answer. But always you should keep third only in the numerator. So try to remove this by multiplying with the conjugate, right? So minus 1 plus square root of 2, this is the answer. So or square root of 2 minus 1, that is option C. Okay, this is the correct answer. This is a simple problem actually. Okay, yeah. So with this, all first 15 questions of multiple choice are done. Okay, let's get into the fill in the blanks. They also carry equal marks. Only thing is you will not have the options. The diagram shows the net of a cube. That is, we can fold along the edges of the squares to make a cube from this net. And each phase there is an integer written -1, a, b, c, d, and 2026. If each of the 4 numbers a, b, c, d equals the average of the numbers on the 4 faces of the cube adjacent to it, the value of a is. Okay, so the question is simple. This is what is given. Okay, now I can fold this very easily, right? I can fold b to this one. So the sides will be a, b, 2026 and c. Top will be d, bottom will be -1. Correct? This is how I will fold it. Now understand which one is opposite to what side. D and -1 are opposite to each other, top and bottom. A and 2026 are opposite to each other. B and C are opposite to each other. Correct? Once you know this one, what they are trying to tell is A, B, C, D are average of 4 numbers which are its neighbors. Means A is opposite to 2026. Correct? But its neighbors are B, C, D and -1. Okay, so A is average of these 4 numbers. Okay, and let's say B and C, and obviously it is same as 2026 also. Sorry, not 2000. They gave only A, B, C, D, right? Which means B and C will have same value because its neighbors are same. Other 4 are its neighbors. So average of other 4 is nothing but B and C. Correct? So if you understand this one, this problem is easy actually. Only thing is there is a twist actually. From the diagram, it is clear which numbers are opposite. We know one A and 2026, B and C, and 1 and D are opposite to each other respectively. Now B and C are equal because it is given this. These are the average of neighboring 4. Correct. So A plus D plus 2026 minus 1, which is 2025 by 4. 4 numbers. Okay. So from this I get one equation, 4B equal to A plus D plus 2025. Okay. Now A is equal to, it is not given that 2026 also average. They did not give. So I am taking only A equal to other 4, which is B plus C plus D minus 1 divided by 4. Okay. So which is 2B plus, because B is same as C. So 2B plus D minus 1 divided by 4. From this I get another equation, 4A equal to 2B plus D minus 1. Okay. Now my D is equal to this value. So from this I get third equation, which is 4D equal to A plus 2B plus 2026. Now I have three variables, three equations. I can solve them. Okay. But problem is, if I solve this one, I get my A value as non-integer. Okay. It's not an integer. Okay. But it is very clearly given that uh, there is an integer written. Okay. These are all integer values. But with this limited information, you cannot get A as integer. So this is something extra information which we need to derive. What we can derive? He did not give whether A and 2026 are same or not. Okay. He said A is average of neighboring 4. But you can assume 2026 also average of neighboring 4. That case, what happens? Both A and 2026 will have same neighbors. So A is equal to 2026. Correct? A is equal to 2026 in that case. So that is the answer. Simple. Okay. And with this value, suppose if you take A equal to 2026 and D is equal to -1, D is equal to -1, then whether B and C it's possible or not, whether you get integers or not. Let's see. 2026 plus 2026 minus 2. Correct? So that is nothing but 52 minus 4052 minus 2, which is 4050. 4050 is divisible by 4. Correct? So that's where you will get your answer. Okay. So A should be an integer. So 2026 minus 1 also average of 4 adjacent sides. Okay. Uh, D and -1 can be equal or not. Yeah, that we can check later. That we can actually decide, because 4050 is not exactly divisible by 4. Correct? 4050 is not divisible by 4. So D can be some other value, but you have to assume A and 2026 are equal. Only then you get the answer for A actually. Okay. This information is not given, but it does not mean that both are not equal. Correct? So that is how we should take the extra information from this question, and then you can solve the problem. So A is equal to B plus C plus D minus 1 divided by 4, which is same as 2026 actually. So both are opposite sides. So A is equal to 2026 is the only solution possible. Okay. Yeah. Next. So this is definitely hard, because from the given information you exactly cannot derive A is equal to 2026. Okay. You have to take that extra step here. Next.
Struggling with Maths Olympiad or Engineering Entrance Prep? Let's make it simple. Welcome to Fun with Mathematics, your YouTube hub for mastering IOQM, JEE, and BITSAT with clarity and confidence. For Olympiad aspirants, we dive deep into number theory, geometry, polynomials, recursive functions, and more, with daily practice problems and complete solutions to previous year IOQM papers. And if you're gearing up for JEE or BITSAT, we've got you covered, with full and cert classes for 11 and 12, solved exercises, and past year questions across topics like trigonometry, complex numbers, calculus, probability, and statistics. Every concept is broken down with tricks, trades, and visual clarity, so you don't just memorize, you understand. Whether it's sets and relations or the binomial theorem, we simplify the toughest topics and help you build real problem-solving power. Subscribe now at youtube.com/@psk99999 and let's make math your strength.
Let S equal to 1, 2, 3, 4, 5, 6 up to 15. The number of subsets of A of S containing 4 elements such that any 2 elements of A differ by at least 2. Okay, which means I have to select 4 elements from this in such a way that no neighboring elements are there. Basically, no neighboring elements means difference cannot be 1, which means at least 2 difference means difference cannot be 1. Correct? So no neighboring elements. Now this is a straightforward combination question actually, which means choose 4 from 1 to 15 such that no 2 are consecutive. No 2 are consecutive, right? So this is straightforward. There is the equation for this one. I'll explain the equation. Picking k numbers from 1 to n items such that no 2 consecutive item is no two are consecutive is given by n minus k plus 1 c k. Okay, n minus k plus 1 c k. So in this case, total subsets are n is 15, k is 4. So 15 minus 4 plus 1 c4, which is nothing but 495. This is the answer. Now let's look at this formula actually, how this has come. This is we can understand very easily. For every number except the last number picked, we need to left next number, correct? You need to, if I pick, let's say 2, I need to leave 3, correct? So for every k picks, basically, for every k numbers, we create k minus 1 skips, correct? So many skips we can create. We have to create actually, because you see, uh, in between numbers are basically neighboring numbers, right? If I pick whatever number I pick, I have to skip one less than that, right? So thus it is picking k numbers from n minus k minus 1 numbers, that is, okay, picking of k numbers from n minus k minus 1 numbers, right? Because k minus 1 I have to skip next time, right? So this is nothing but n minus k plus 1, n minus k minus 1, which is nothing but n minus k plus 1 ck. Okay, that's what this formula is. Yeah, if you know this combinatorics formula, then it is straightforward. You should remember this is a very common question in 11th and 12th. Okay, but I would still give it a moderate, because yeah, you need to remember this formula here. It's difficult to derive from here actually. Okay. Given a deck of 52 numbers with numbers 1, 2, 3 up to 52 written on them, one number per card. Okay, the deck is shuffled and 13 cards are chosen at random from the shuffled deck and thrown away. 13 cards are removed without noting the numbers on them. Okay, from the remaining 39 cards, one card is chosen at random. If the probability of that number on that card is a multiple of 13 is m by n, where m and n are integers and no common divisor, basically in the minimal form. Okay, then m plus n is equal to. Okay, so this is also a very, very fundamental conceptual question. If you know it, it's just a straightforward question actually. Okay, you should know. 13 multiples among these 1 to 52 are 4, 13, 26, 39, 52. That means each 13 cards have one 13 multiple. Each 13 cards have one 13 multiple, and there are 4 such decks, right? Just like a standard cards deck, okay, playing cards deck. Removing 13 cards does not bias anything, right? And the remaining cards, because you are randomly removing them. Probability that those 13 cards are 1 to 13, I mean multiples of 1 to 13, is equally likely, right? Equally likely event, that is. Which means if you remove the 13, other 13 are still will have 3 multiples of 13, because every 13 cards, one multiple of 13 will go away if I pick randomly, correct? So it won't bias anything actually. So answer is still 1 by 13 or 3 by 39, which is 1 by 13. Okay. The probability of picking 13 multiple from the remaining 39 cards is 3 by 39. Okay. Okay. Or it is same as picking 4 from the 52 cards. All are same basically. Or 1 from 13 cards, which is same. Okay. So the simplest form is 1 by 13. Okay, 4 by 52 or 3 by 39, you can write it in the form of 1 by 13. So m by n, which is equal to m by n. So m plus n is 14. Okay, this is the answer. Okay, note that in every 13 cards, there is one 13 multiple. Hence, after removing 13 cards, we still have 1 by 13 probability in other set of 13 cards. Okay, this is what you need to understand. Okay, so this is also moderate because it's a conceptual question. So you should know this concept. Okay. If you know the concept, this is very simple. Okay, it won't bias actually anything. Removing random 13 cards won't bias anything. Okay, next. Suppose 10 objects are placed along a circle at equal distances. The number of ways can 3 objects be chosen from among them, so that no two of the chosen objects are adjacent or diametrically opposite. Okay, means if I choose 1, then I cannot choose 10 and 2 and also 6. These 3 I cannot choose. So one thing is I can go by selecting first number, second number, third number, and make the probabilities. Other way easy is, first thing is selection of 3 from this 10. Okay, is 10C3, correct? Now I want to subtract how many adjacent, how many diagonally opposites are possible. Simple. Okay, so one case one is all 3 can be adjacent. Okay, if all 3 are adjacent, okay, how many possibilities are there? All 3 adjacent. I have 1, 2, 3, 2, 3, 4, 3, 4, 5, 5, 6, 7, 6, 7, 8, 7, 8, 9, 8, 9, 10, 9, 10, 1, 10, 1, 2, which is basically 10, because each one is starting with 1 to 10. So 10 possibilities are there where all 3 are adjacent. All 3 adjacent objects are picked. Okay, so I should subtract this. Selecting all three adjacent objects is 10. Now, second option is 2 are adjacent, not 3. Okay, so this is the possibilities. Anyway, selecting two adjacent objects is 10C1. Okay, why? Because I have, if I combine them into two groups, okay, 1, 2, 2, 3, 3, 4, 4, 5, I still get 10 objects. Out of them, one I have to select, right? So 10C1, and this is I have selected two objects, correct? Now, third object I can select, it should not be adjacent to this, adjacent to the selection, which means I am left with 1, 2, 3, 4, 5, 6, correct? If I select these two, I have 8 objects basically. Next selection, and next select the third object, which is 10C1 among the 8, okay, remaining, minus 10, where all three adjacent uh, are possible, right? So I should not select adjacent. Adjacent, how many possibilities are there? If I select any of the remaining 8, okay, there are 10 possibilities that all three will be adjacent, correct? One already I selected adjacent, okay, 1 and 2 I selected. What is the possibility of selecting uh, from this other adjacent, right? So 10C1 into 8, okay, but this can form all three adjacent. How many of such? We know that is 10, so minus 10. Okay, so this is nothing but 70. 80 minus 10, which is 70. Now, diagonally opposite we should check. Number of diagonal pairs are 5. I can make 5 pairs, so choose one of them. Okay, I choose one of them, 5C1, which is 5 ways. Next one should not be adjacent, because adjacent I already counted in this. I don't want adjacent. Okay, so if I choose 1 and 6, let's say, the options I have is I cannot choose 2, 6, 5, 7, right? So what are the options I have? 4. Other 4 options I have, 8, 9, 3, 4 I have, right? So selecting next non-adjacent is 4C1, which is 4. So total diagonal selection options without non-adjacent diagonal selection is 5 into 4, which is 20. Okay, so all these three I should subtract from this one. Okay, so required ways of selection is nothing but 10C3 minus 10 minus 70 minus 20, which is, this is 120. So 20 is the answer. Okay, next. Yeah, this is definitely hard problem. You need to understand multiple conditions here, right? Next. For a positive number n, let n mod 13 denote the remainder when divided by 13. Okay, the remainder theorem uh, information he gave. If a, b, c are integers such that 4a plus 5b plus 6c is congruent to 1 mod 13, a minus b minus 7c is congruent to 3 mod 13, 3a minus 4b plus 5c is congruent to 9 mod 13, then what is the value of a plus b plus c mod 13 is? Okay, so first write the three equations which are given. Okay, so that means this number when divided by 13 leaves 1 remainder, this number divided by 13 leaves 3 remainder, this number divided by 13 leaves 9 remainder. Okay, now all I need is a plus b plus c, correct? Mod 13, or if you prove that any one of them is 13 multiple, you can ignore it, right? That is also possible. So you try to get a plus b plus c by doing row operations. If you consider this as matrix, the quotients are the matrix elements, you need to do row operations to get a plus b plus c. Okay, so closest one I can see is basically, okay, 1 minus 3, 1 minus equation 1 minus equation 3 gives me, okay, a plus 9b plus c congruent to 1 minus 9, which is minus 8 mod 13. In remainder theorem, minus 18 means, okay, the number with which you are dividing minus that number, right? 13 minus 8, which is 5. 5 more 13, this means. Okay. Now, next is 3 minus 3 times 2. Okay. 3 minus 3 times 2. This gives me, okay, minus b plus 26c congruent to 0 more 13. Okay. Which means this is very important thing. Okay. Because this actually tells me that b is a multiple of 13. How? Because 26c is already multiple of 13. So this will give me 0 remainder. This also, b also should give me 0 remainder. Otherwise, I don't get 0 here. Correct? Which means b mod 13 also, b congruent to 0 mod 13. Okay? This is important to note. Once you know this, this is very simple. Now, all I need is a plus c. b is anyway 13 multiple. Correct? b is anyway 13 multiple. So all I need is a plus c. So from this, A plus C is congruent to minus A 5 mod 13. Okay, 9B is anyway A plus B plus C. I can also congruent to A plus 9B plus C, because B is anyway 13 multiple. 9B also 13 multiple, which will give me 0 remainder. So this will not affect anyway the remainder. Okay. So A plus C. If A plus B plus C, among that, this is 0 remainder. So A plus B is what important for me. Okay. So I'm writing this as A plus 9B plus C, which is same actually in remainder, which is giving me 5 mod 13, which means A plus B also, when it is divided by 13, gives me 5 remainder. Okay. Hope you understand this logic actually. Okay. So remainder is 5. That's it. That's the answer. Okay. Yeah, it's moderate. Little bit logic you need to understand from this point. Okay. So I would say moderate. Okay. So overall, actually, this NMTC has very good remainder theorem problems. Okay. So you should be practicing more and more remainder theorem problems. Okay. Next. Okay. Forget this answer. The sum of all positive integers n less than 2024 such that n equals 13 times the sum of digits of n when written in base 10. Okay, is. So all such problem, this is a 4-digit number, correct? So I take 4 digits as ABCD. So the number be ABCD. Okay, ABCD are digits here. Okay, now 10Q plus A plus 10 square plus B plus 10C plus D, which is the number expansion basically in 10 decimal method, is equal to 13 times the sum of digits. Okay, so this one, correct? Now, if I simplify this, this is nothing but 387A plus 87B equal to 3C plus 12D. Simplify further, divided by 3. You get 329A plus 29B equal to C plus 4D. Now, I know my restrictions. A is 0 to 2 because n should be less than 2000. Correct? And BCD can be 0 to 9 anything. Okay? So, now I just need to apply my conditions properly. Okay? Maximum of C plus 4D, this side is, okay, C and D can be maximum 9. So 9 into 5, which is 45, which means 45 when it will be, even if A is 1 minimum number, this is 329. It is more than 45. Okay, so it's not possible. So A has to be 0. Okay, so A is 0. So next condition. Okay, now you have 29B equal to C plus 4D. Correct. So let's take B equal to 1. If B is 1, then 29 minus 4D equal to C. Okay, then my D comma C I can make pairs actually, or C comma D, whatever. D comma C is 5 comma 9, 6 comma 5, 7 comma 1. This is equation is satisfied by these 3 values only. Okay, now let's take B equal to 2. If B equal to 2, what happens is 58 minus 4D. Okay, so D, even if you take 9, 36, so it will give 2-digit number, which is not possible. Okay, so B 2 onwards, it's not possible. So only option is these 3 values. So if you write them properly, the numbers are, this is D comma C, not C comma D. Okay, so 195 because B is 1, 195, 156, 117. Okay, sum of all the 3 values is 468. That's the answer. So this is a fairly easy problem. Okay, next. 6 identical rectangular regular hexagons are arranged inside a larger hexagon as shown in the figure here. Okay, there is one big hexagon, regular hexagon. Inside there are 6 hexagons are arranged. Okay, center also got a hexagon which is of same size. Okay, now what you want is the outer hexagon area is 900 square units. Okay, the area of the shaded region, that means only these 6 hexagon area is how much is asking. Okay, so now let's say the inner hexagon side is A. Okay, if this is A, this is also A, correct? So in the outer hexagon I have 7 hexagons arranged and then some triangles. Okay, these triangles 1, 2, 3, 4, 5, 6, I call them big triangles, are of same size. There are 1, 2, 3, 4, 5, 6 other 6 of small triangles. Okay, the bigger triangle side is A and A, correct? Bigger triangle size is, this is A, this is also A. So A and longer size. Okay, smaller size is, the longer side is A and there are 2 equal sides. And now the angle is important. Okay, the angle here is 120 degrees because this is hexagon angle is 120 degrees. I know 120, 120. So the remaining will be 120. And this is anyway hexagon internal angle. So which is 120. So this is 120 degrees. This is also 120 degrees. Okay. If this is 120 degrees, I know the area of this bigger triangle, which is A into sine theta. correct? A square, half into a square sine theta, sine 120, that is. This is bigger triangle area. This one I can easily find out. This is 120 degrees. So apply sine rule here basically. Sine 120 by A. Okay, and what are these two angles? Because these two sides are same, 30 and 30 you will get, correct? 30 and 30. So sine 120 by A equal to sine 30 by x. You can get x in terms of A. Now this is also x. Now I can get my x square into x square by 2 into sine 120. This area also I'll get. Okay, so this is 6 triangles, 6 such small triangles, correct? So required area is 900 is equal to actually total area 7 hexagon areas, 6 big triangles, 6 small triangle areas, correct? Now 900 equal to hexagon area, okay, is 7 times this A, right? Side is A. So hexagon area is 3 root 3 by 2 A square. You can form it into 6 equal triangles and then find out easily. Okay. So 7 times 3 root 3 by 2 A square plus 6 big triangles is 6 by 2 into A square sine 120 degrees. That is this. 6 small triangles is 6 times 3 by square root of 3 by 12 A square. Okay. If you find out this x here, that's what you will get. Okay. Now just simplify it. You will get A square value, correct? Your A square is nothing but 24 square root of 3. This is my A square. Now all I need is 6 hexagon areas, which is 6 times this value, correct? So shaded area is nothing but 6 times 3 square root of 3 divided by 2 A square, and A square is 24 square root of 3. If I substitute, I get the answer 648 square units. This is the shaded area given in this. Okay, hope you understand. This is a simple problem. Looks complicated, but you break down into smaller problems. Okay, it's very easy. Next, a positive integer is said to be special if sum of the remainders obtained when it is divided by 5 consecutive positive integers is 32. For example, 24 is special since it is divided by 11, 12, 13, 14 and 15. The remainders are 2, 0, 11, 10 and 9, and these add up to 32. What is the smallest positive integer that is special is? Okay, so it has to be less than 24, we know. Otherwise, 24 is the minimum, correct? So one thing is counting method. You cross check 1 to 23. It's very easy actually, not so complicated, correct? Just a reminder, that's all right. So other one is, let's do this way. Okay, when a number is divided by a bigger number, it leaves the same number as remainder, which means if I divide 8 with 9, its remainder is 8. 8 with 10, remainder is 8. 8 with any number more than 8 is remainder 8. Correct? Now, all I need is 32. 32 means there are 8 into 4. 4 8s are already there. So, 9. If I divide 8 with 9, 10, 11, 12, I get 8 remainder. 8 into 4, 32. And 8. Correct? So, which is straightforward answer. Actually, 8 is the answer. That's the minimum. We need to prove that 8 is the smallest. Okay? Let's do this way. Okay, so one thing is, yeah, this is what I explained just now. The sum of 5 remainders should be equal to 32. So on an average, each remainder should be around 6. Correct? If it is smaller, then it is very difficult to make 32. Sum of 32. Okay, so around 6. So minimum the numbering counting you should start is from 6. Before 6, you will never get 32 remainders. Sum of 5 consecutive numbers you will not get. Okay, correct? So because if let's take 5 and it leaves complete remainder. Okay, all 5 is remainder. So 5 into 5 also 25 only you'll get. 6 is also not, 6 is possible because 6 into 6 is 32. If one of them is leaving only 2 remainder, then you will get your answer, correct? So you start checking from 6. Okay, or 7. Okay, I am checking from 7, but you can start checking from 6. So let us check from 7 here. 7 divided by 8, 9, 10, 11, 12. Okay, then I am getting around 7 into 5, which is 35. Very close. If I take any other number less than this, 7, 8, 9, 10, 11, then one of them will become 0. Obviously, I will get less than 32. Okay, so this is not possible. You can cross check with 7, 8, 9, 10, 11. Okay, it's not possible. Now, next, go to 8. Okay, so if you take 8, 8 is divided by 8, 0. Then other 4 numbers, I'll get 8 remainder. So 8 into 4 is 32. So this is the one. Okay, this is the only one, and we have to check from 6. So we checked. We can check 6 if you want. Okay, Then 7, we checked it is not possible with 7. So 8, it is possible. So 8 is the smallest such number. Okay. Yeah, this is easy actually. It's a counting method, and you know from where to start. You have to just try 2 or 3. Even if you don't put any logic, checking from starting from one onwards, it's very easy to find out that 8 is the answer. Okay. So next, largest 3-digit number with the property that number is equal to the sum of the hundreds digit, the square of the tens digit, and cube of its units digit is. Okay, so this is also similar to the problem one problem which they gave in the digits. Okay, you will call the number as ABC. Okay, now the actual number is the expansion 10 decimal number expansion is 10 square A plus 10B plus C, which is equal to, okay, sum of hundredth digit, which is A, square of 10 digit B square, cube of units digit C cube. Okay, so this is what the given equation is. Now once you know this one, it is all about simplification. So 99A equal to B square minus 10B plus C cube minus C. Okay, next 99A is nothing but B into B minus 10 plus C into C minus 1 into C plus 1. Okay, continuous 3 digits here, correct? Now B into B minus 10 is always negative, correct? This is always negative. Okay, this is positive. So obviously this has to be positive, correct? So if this is negative, take it to the other side, make it positive basically by, instead of calling it minus B into B minus 10, I made it 99A plus B into 10 minus B. Okay. Now next, max of B into 10 minus B is 25, but B is equal to 5. Correct. This is the max I can get. Okay. That is this number. This is maximum is 25. Maximum of this number is, okay, maximum of this one is 720 when C is equal to 9. Okay, when C is 9, this is the maximum I'll get. Okay, 720. This is 25 max, this is 720. So I should try to get correct. So if I cross check this one, 99 into 7. Okay, 99 into 7. Okay, if this is 70, the max of this one is 720. 720 equal to 99 into 7 plus B into 10 minus B. So B into 10 minus B, I'm getting only 27. Okay, which is not possible because 25 is the max value, right? 25 is max. Next, let's take C equal to 8. C equal to 8 because 9 is not possible, right? So I'm going down. C equal to 8. C into C minus 1 into C plus 1 is 514. Now again apply the same rule. 514 equal to 99A plus B into 10 minus B. So if I simplify it, A equal to 5. Okay, B into 10 minus B is 19. Okay, and B into 10 minus B has no factors. 19 because it's a prime, right? So this is not possible. B cannot be 2-digit number, correct? One of them should be 2-digit number. It's not possible, correct? If this is 1, this will become 9. So this is not possible condition again. Now C equal to 7 you take, C cube minus C is 336. So 99A plus B into 10 minus B equal to 336. So you take this as 3 approximately, correct? And you cross check, you will not get any possible solution for this one also. Okay, at C equal to 5, similarly you keep trying, you will get this is a counting method, right? Finally, at C equal to 5, C cube minus C equal to 120. So 99A plus B into 10 minus B is 120. At A equal to 1, what happens is this is 99. So B square minus 10B, or B basically B square minus I'm taking everything to one side basically. B square minus 10B plus 21 equal to 0. This is the quadratic equation you will get. You solve it, you get your values. B is equal to 3 and 7. Okay, these are the two values where this is possible. Okay, the largest 3-digit number with that given property is possible. So possible numbers are 135 and 175. Okay, so what is the question also? Largest 3-digit number. Largest number we want. So answer is 175 out of this. Largest is 175. This is the answer. Okay. So yeah, definitely this is moderate. Okay. Next. It's a surprising fact that 1 into 2 into 3 into 4 into 5 into 6 can be written as 8 into 9 into 10. Okay. It is more surprising that 8 into 9 into 10 into 11 into 12 into 13 into 14 can be written as a product of consecutive positive integers. what is the smallest number of this product. Okay, so this is very clearly it's a trial and error method or accounting method basically. Okay, so only thing is what is your starting condition, terminal condition you should know, right? So 8 into 9 into 10 into 11 into 12 into 13 into 14. You look at this, there are two primes actually. 11 and 13 both are primes. If you are writing this as a product of any number of consecutive positive integers, okay, these two cannot be, these two should be, it should be multiples of these two, right? Either 11 or 13 or both of them. It can be anything, right? So start looking at multiples of 13 and then rewrite the product. Okay, so let's start with the let's say 13. Okay, 26. 13 multiple is 26, right? So start with that. I'm taking bigger one out of these two primes because the bigger one you take, it is easy to conclude faster, right? Because you cannot go further. Okay, so this can be rewritten as, if I take 2 from here, it will be 4 into 9 into 10, 11, 12, 26 and 14. This I'm fixing 26. So I need to get 27, 25. Okay, is it possible from anywhere? You can check. Actually, there is no 25 possible, right? So I have to go only 27 and above. Okay, there is only one single 5, right? So next is 27. So 9 into 3 is possible. So 27 I can get, 28, 14 into 2 I can get, 29 is a prime again. So it is not possible. 29 is a prime. So I can't get from any of these products. So it's not possible. 25 also not possible. So this is not possible. So go to next multiple, that is 39. Okay. So I will rewrite this as 8 into 3 into 10 into 11 into 12 into 39 into 14. 39 I am fixing. So I have to go down or go up. Okay. Go down, I can go maximum 38. Okay. Nothing more than that because 37 is a prime. Okay. So I can write 39 into 40 because 10 is there. Okay. Into I can take 4 out of any one of this. Okay. But after that 41 also prime. Okay. So now this is not possible. Right. So stop it here. Third one, you take 52. Again, you will have same problem. 53 is a prime. Okay. And 51 you cannot get because you need 17. 17 into 3 is 51. So 17 is a prime which you cannot get from this one. Okay. So next one is 65. If I take 65, okay, 66, 64, 63, 62. So many options I have, right? So let's make it. 65 is there. So 66 I can make 11 into 6. Okay. So 11 into 6 is 66. Okay. Then 64 I can make 14 into 6 is 64. Also, not 14 into 6. 64 I can make 8 into 8 actually. Okay. 8 into 8 I can make. So 65 into 66 into remaining is 8 into 9 into 2 into 2 into 14. Okay. So 8 into 8 is 64, which is 2, 2 and 2 from here. Okay. Now 9 into 7 remaining, 9 into 7 is 63. Okay, so this is nothing but 63 into 64 into 65 into 66. This is the simple trial and error method. So now the question is smallest number in the product is, which is 63. That's the answer. Okay. Yeah, this is definitely easy question. Might take some time, but complexity wise it is easy. Next. There are 100 points P1 to P100 placed on a line such that the distance between Pi and Pi plus 1 is 1 by I. For I is between 1 to 99. The sum of the distances between every pair of these points is, okay. So if you draw a line, this is how it looks actually, P1 to P100. Okay, 1 by 1 is here, this one. Okay, not exactly here, it's pointing wrong. Okay, 1 by 1 is between these two, which is 1 by 1, and P2 to P3 is 1 by 2, P3 to P4 is 1 by 3, and so on. And P99 to P98 to P99 is 1 by 98, P99 to P100 is 1 by 99. Okay. Now sum of each pair you need to calculate. Okay. So first take it sum from point P1. Point P1, what is the total sum of all the points, each point? First one is 1. We know P1 to P2 is 1. P1 to P3 is 1 plus 1 by 2. Okay, then 1 plus 1 by 2 plus 1 by 3 and so on. It will go like this, 1 plus 1 by 2 plus up to 1 by 99. Correct? Up to P99. Now this you can reshuffle in this way. Okay, you have 99 ones. Okay, 98 1 by 2s, 97 1 by 3s, 96 1 by 4s, and only 1 by 99. Okay, now sum from P2 to all points. Next is already P2 to P1, you don't need to check because it is done already, calculated from P1 to P2. So P2 to Again forward P2 to P3, P2 to P4, P2 to up to P2, P2 to P100. Okay. So in this case, P2 to all the points other than P1. Okay. P1 is already calculated in this. Okay. So it starts with 1 by 2 plus 1 by 2 plus 1 by 3 plus so on up to 1 by 2 plus 1 by 99. Okay. So now in this one, only thing missing is all 1 plus is missing basically. This 99 ones are missing. Okay. Remaining all same. Okay. Which means 98 1 by 2 is 97 1 by 3 is 96 1 by 4 is up to 1 1 by 99. Okay. Now you can see the pattern, right? There is a pattern. Every time you go to one next point, basically you will skip one of it 1 by 2. Okay. And remaining will be same. Okay. Remaining will be same. Correct. So now put it in the format. From P1 all the points, this is the sum. From P2 this is the sum. Okay, you will have second option. From P3 you have from 97 onwards. Okay, and so on. Correct. So total sum is you will have 99 ones as is, 98 half plus 99 half is 98 halves into 2, 97 1 by 3 is into 3. Okay, and so on. 96 1 by 4 is into 4. And 1 by 99 into 99. Okay, so now if you can easily cancel this one, this sum is nothing but 99 plus 98 plus 97 up to 1, which is sum of first 99 integers, which is 4950. This is the answer. Okay, I'm sure this is easy, but only thing is you just need to get this idea of finding the repetition basically, right? So medium. Next. For any positive integer n, let d of n denote the number of divisors of n. For example, d of 4 is 3 because the divisors are 1, 2 and 4. The smallest positive integer n for which d of n minus 2 plus d of n plus d of n plus 2 is 21. Okay, so this is also again a simple trial and error method. Okay, so only thing is, yeah, you need to know the condition from where you should start. Okay, first thing is remember one formula for calculating number of factors. Any number given, you put it in the prime factorial method. Okay, so if n is written in prime factorial method, example I am giving here. Okay, I am taking only 2 3 and 5 are the primes of this n. Okay, 2 to the power of k into 3 to the power of l into 5 to the power of m. Okay, this is the prime factorization. Suppose if n is written in this form, then number of factors is nothing but powers you take k plus 1 into l plus 1 into m plus 1. Okay, you know this formula, and with this you can solve this problem very easily. Trial and error method, that's it, simple. Okay, since the total is 21, you take 21 by 3, each one I'm average you should get 7 factors, so you choose a number wisely. Okay, so I am choosing 24 because factors of 24 are around 24. I can write it as 2 cube into 8. Correct, 2 cube into 8, so 3 plus 1 into 1 plus 1. 3 plus 1 is 4, 1 plus 1 is 2. Okay, so 4 into 2, which is 8. 8 factors are there. So I'm choosing this number. Okay, now I have to go, if this is 24, I have to go 26 and 22. Correct. So D22 plus D24 plus D26, if I check, this is very small, just 16, not close to 21 actually. Okay, so take another number. Okay, D36, if I take, this is 2 square into 3 square, means 2 plus 1 into 2 plus 1, which is 3 into 3. 9 factors are there. Okay, I'm using this method basically. Okay, now this is a good number. 9 is a good number. So I will go D38 and D34. Correct. So D34 and D38, if I take, D34 and D38 has very few factors actually, only 4 factors. Okay, so 4 plus 4, so still I am not reaching. I am just 9 plus 8, which is 17, just one more than this. Okay, but since D36 is a good one, try with this. Maybe you can go this side. Okay, so D36 plus D38 plus D40. Okay, so 9, this is 4. D40 has 4 into 2, which is 8. So if I count now, this is 21. Right, so my n is nothing but 38. Okay, this is the smallest positive integer. Okay, for which this equation is possible. 38 is the answer. Okay, this is the simple trial and error method, and there is no complexity actually, so this is easy. Next, two bugs sit at the vertices a and h of a cube a b c d e f g h with edge length 4 square root of 110 units. The bugs start moving simultaneously along AC and HF with the speed of the first bug twice that of the other one. The shortest distance between the bugs is. Okay, so you first draw the diagram. Actually, this looks something like this. Okay, you have A, B, C, D. Okay, then A, B, C, D, E, EFGH. Okay, EFGH. Now there are two bugs. One is moving from A to H in this direction. A and H. It is moving. A to C and H to F. Okay. Now only thing is the one is moving at speed of v, other one is moving with the twice the speed, that is 2v. Okay, now this problem you need to solve. What is the minimum distance between these two, smallest shortest distance between these two bugs actually at any given time. Okay, so this you can solve using the coordinate system. Okay, so let us fix E as the origin. E as the origin of the 3D coordinate system. So coordinates of E are 0 comma 0 comma 0. Now I am all interested in A, C, H and F, correct? So A coordinates is only at the vertical direction. Okay, if you take this as Z, okay, this is X, this is Y, this is Z, then this is only Z coordinate, right? So bug one route is from A, which is 0 comma 0 comma S, to S comma S comma S, which is here. Okay, what is this? S is nothing but side of the cube. Okay, side of the cube, which is 4 square root of 110. Okay, I'm just putting denoting with a variable, that's all. Okay, constant of bug 2 root is H, which is 0 S comma 0. This is 0 S comma 0 because this is Y coordinate, X, Y, Z. That's what we took. Okay, towards X, that is S comma 0 comma 0. Okay, now we know that bug 1 is moving at 2v speed and bug 2 is moving at v speed. Okay, so now bug 2 position in time t is nothing but, okay, in time t with a velocity of v, it can travel some k distance, correct? So k distance is increasing in, k distance will increase in x coordinate and decrease in y coordinate, correct? So x coordinate whatever is increased, that is the decrease in the y coordinate. So k increase, s minus k. Similarly, the second bug 1 is in position, bug 1 position in t time is, okay, this is going at 2v, twice the speed, correct? So 2k will be the distance in t time. So from 0 comma 0 comma s to s comma s comma s, it is moving. That means x and y coordinates will increase by 2k comma 2k in t time. Okay, so now this is the coordinates in the runtime. Right now all I need is the distance between these two coordinates, which is if I take d square, distance is d square, square root I am just eliminating. It is nothing but square root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square, which is k square plus 3k minus s whole square plus s square, which is simplified here. Now out of this, which is s is a constant, k is a variable. So this is a quadratic equation. We know that smallest value of the quadratic expression is at minus b by 2a. If you don't remember that, you can do differentiation with respect to k here and you will get the same answer. Okay, so this is a quadratic equation and k minimum is minus b by 2a. B here is minus 6x by 2a is 20. So minus 6x by 20 is nothing but 3s by minus of minus basically. Okay, 3s by 10. This is my k minimum. Now substitute this k minimum in d square. Okay, what I will get, d square is 11s square by 10, or d minimum is square root of 11 by 10 s. Okay, now all I need is s, substitute s, which is 4 square root of 110. Okay, so d minimum is nothing but 44. This is the answer. Okay, hope you understand this problem. A simple trick, but yeah, this is a moderate, or I would say a moderate to hard question, because you need to understand that the speed is nothing to do with here. It's all distance we have to calculate. Okay, so yeah, this is one good question here, hard actually. Yeah, next. The smallest positive integer n, for which it is possible to draw a n-sided polygon, whose vertex angles are all measured in 163 degrees or 171 degree. Okay, yeah, this is a simple one. Let there are x vertices with angle 163 degrees and y vertices with 171 degrees. Okay, so all I know is 163 into x plus 171 y equal to sum of n polygon angles, internal angles, which is n minus 2 into 180. Correct, so which is nothing but 180 n minus 360 if I expand this one. Okay, now if another equation I know is x plus y, total number of vertices is equal to the total number of sides, which is n, x plus y equal to n, or y equal to n minus x. Now replace this here. Okay, so if I replace it, I get an equation with a relation between x and n here. Okay, which is nothing but 8x equal to 360 minus 9n. Okay, Now x is equal to 360 minus 9n by 8, or y is equal to, if I take y, x plus y equal to n, right? Y equal to n minus 360 minus 9n by 8. Okay, once I know this one, this is simple. I need to only simplify the conditions basically. We know that y is greater than or equal to 0. Okay, it is a positive number. Okay, so that means this n minus 360 minus 9n by 8 also greater than or equal to 0. So which gives me a condition that 17n is greater than 360, or n should be greater than 21 dot some decimal fraction, right? That means n should be greater than 21. Because this is one condition. I can also derive second condition from this one. Okay, 8x equal to 360 minus 9n. Okay, now I need to check n greater than or equal to 22. Right? Keep checking now. At n equal to 24, okay, you get the answer. At n equal to 24, 8x equal to 360 minus 216, which is 144. So x is 18 and y is 6. Okay, total is 24. Okay, so the answer is basically the smallest positive integer n, that is what is asked, which is 24. That's the answer. Okay, yeah, this is a moderate question. Next, last one. Yeah, let p of x function is defined as, our polynomial is defined as ax cube plus bx square plus cx plus d be a cubic polynomial such that p of 2 equal to 7, p of 3 equal to 13, p of 5 equal to 7. If sum of 3 roots of p of x is 40, then what is p of 35? Yeah, basically you need to find out a, b, c, d, okay, and then make the polynomial and then get the p of 35 value. Okay, this is the easiest way. There are other ways using uh, uh, remainder theorem problems. You can do it, but that is bit complex. The easy method is this one. This is not very complex to solve a 4 variable equation using 4 equations, right? So that's easy. So first thing I know is sum of 3 roots is p is 40. So sum of 3 roots from this expression is minus b by a, right? So minus b by a is 40, or minus b equal to 40a. Okay, next p of 2 is this value, okay, which is equal to 7. And if I substitute minus b equal to 40 or b equal to minus 40, I actually eliminate one variable, which is b. So minus 152a plus 2c plus d equal to 7. Similarly, I can form p of 3. I get minus 333a plus 3c plus d equal to 13. From p of 5, I get minus 875a plus 5c plus d equal to 7. Now, very clearly I can see I can make this very easily into 2 variable equation. 2 equations I can make into 2 variable by you subtract these two, d will go off. You subtract these two, d will go off. So you will have 2 variable equation and 2 equations, correct? Which you can easily solve. So that's what I am doing here. Okay, so you can do it whatever way you want. Okay, and what you will get is a is 0.1, c is 24.1, d is minus 26, and b is nothing but minus 40a, which is minus 4. Okay, so my polynomial is 0.1 x cube minus 4 x square plus 21.1 x minus 26. So p of 35 I have to substitute, which if I calculate carefully I get 205. This is the answer. So solving this is easy, nothing much, but calculation is a little bit, yeah, lot of mathematical calculation you have to do. So I would say moderate. Okay, so these are the 30 questions in the stage 1 of NMTC. Okay, so I think these are a good set of questions for students who are preparing for 𝑖𝑤-𝑘𝑚 and other Olympiad problems. Also, it's good for students who are preparing for 11th and 12th also. Okay, so I will do in my next video stage 2 also. Okay, until then, keep checking this video and other Olympiad videos and keep preparing yourself. Thank you.